Hey guys, I'm gonna, so first let me present you the Dreamcatcher team, because we're like a bunch of us, like 5 guys. Tom, our developer, Jay, Nicolas, Henrik, and from my friend, yeah,
people for basketball. All right.
So what is the problem we wanted to solve? Basically in 2 days we wanted just to reinvent one very important process being involved in the construction industry, which is the issue management on sites. And I'm sure PK can say a few words about how painful it is as an architect to go on site with all the blueprints, to mark on the papers where the issue are located. It's just a nightmare.
Yeah, right now we carry bits of like A4 paper and A3 paper, and then it gets like torrential rain. I'm on a motorbike, it gets wet by the time I'm there, and then we lose papers on during the sidewalk. And then what happens? And then you take photos. I go there with my smartphone. If I'm lucky, my contractor guy will take it when I say like take that, and then most of the time he takes the wrong thing, and then I have to check. I'm also talking at the same time, so he's also trying to take notes. So he's got the multitask, I got the multi-thing. It's a nightmare.
So, thank you, Philip. And fortunately, I mean, Final Cut has a solution, but I'm not here to talk about Final Cut actually. But what we can see is that actually mobile applications are just killing paper right now on construction sites. But still, the process is still a bit heavy, because basically you are getting your blueprints on your iPad. You need to open the blueprints to find where you are, and then to localize the defect on one image. So if you are like me, you have some trouble to figure out where you are in space. It's just a nightmare, and you can like put a defect on the left and it was on the right hand side of it. Okay, so basically what we want to do is just to kill the blueprints out of these applications. What you just want to do is to the dream. I mean, the dream for architects or for a general contractor would be to have this kind of scanner where you would like target the issue, shoot it, and then it's okay. Your issue is localized in space, and then you can go around and go to another space to proceed your visits. And it's what we wanted to achieve in 2 days was the proof of concept that the technologies were here to make it happen. So we decided to try to develop one proof of concept based on the Tango project. Okay. So catching the defects is one thing, and afterwards, what we wanted to just to demonstrate is that you can easily send the data to one BIM model to localize all the data collected in space on a digital model. Okay. So basically, in 2 days, we just reinvented this inspection scenario. The scenario, we may distinguish 5 steps in this scenario. So the first step is just, okay, jump into the room. Then you do some small model calibration to match virtual reality, to match your digital model to the reality. Okay, it's a matter of matching two frames. Then you start your visit, so you start scanning and shooting the defects. You export the data to Flux, and finally you can do some some 3D data analysis on tools like so we're gonna jump into these 5 steps. So the first thing we wanted to do is just to find a room that will be suited for Tango scanning. Okay, so based on a few past projects, like the Whiskey project, which happened five months ago, we chose one particular space. So this is the TV room here, where the distance are not higher than like 4 meters, so it's perfect for 3D scanning. And actually, for our problem, to solve the problem we wanted to solve, the accuracy of Tango was not a problem, because we just wanted to localize issues in space. You don't need to be accurate at like 2 millimeters. If you have an error of 10 centimeters in one big room, it's not a problem. Okay, step 2, model calibration. So we didn't have time. Oh, I'm sorry. So here, Jay modelized the space like in 1 hour using SketchUp.
Yeah.
A fast modeler, because we needed this digital model to then match the issues in a virtual world. Okay. So second step, model calibration. So you need to make the match between virtuality and reality. So we didn't have time to implement that. There is a past project who worked on that. Actually, we just need to match 2 points, because you are keeping. I mean, you have other you can define other constraints, which are use constraints that will end in just 2-time definition necessary to get this final matching. Step 3. So this is the app development, the Tango prototype, and Tom is gonna say a few words on that because it was made of his job during these 2 days and 1 night.
Yeah, good. So it's been really interesting trying to learn all this stuff. I'm not actually an Android developer, so this has been like a really steep learning curve. But I eventually got a really hacky Android app working that does the bare minimum things we wanted to do. So there's 2 things I wanted it to do. One is use one of the Project Tango example, or base heavily on one of the Project Tango example apps to just grab a bunch of points in space. And then 2, send those up to Flux, and from Flux then we can pull them down into different applications where the other people can use them, as you'll see in the next step. So is one part I just, the first thing you have to do is like log into Flux. So so this is this flow happening. And then once that is done, then I'm logged in and I can see my projects. This looks like a bunch of gibberish data, that's because it is, but if you pass this correctly, it is just your list of projects and stuff. And then, so once I've done that, then I can go back to the actual Project Tango sort of like portion of the app. And this is going to be really hard to show you all because I can only show you this tiny screen. So I guess I'll show the camera mostly because then more people can see it later. I don't know. But basically you select, well, okay.
Well, you could Chromecast this.
So this is just crazy. You just pointing defect like this. It's
yeah, okay. And I think
When
the
it
light's
works.
really freaking it out.
it works. Yeah.
No, when it works.
It is
The
working.
TV is reflecting
Yeah,
the
yeah.
IR. Let's try
It's
this.
Oh, it's because the room is too. This room is too big.
Well,
We are not.
no, that's not the point. What's going on is the TV is reflecting the
Yes,
IR
yes.
and it's like freaking out about that.
Yeah.
Okay, let's see. The screen is just flashing at me now, so. Okay, well, just imagine that bit worked. I guess this is always how it goes, right?
You can always restart it and then do it for the camera. Later.
Yeah, exactly. Maybe I'll just do that. The screen at this point is just like flashing.
Don't, yeah, no, it's already,
like
corrupted.
sad.
It's already corrupted.
It worked just now.
Okay, there are some people in this room who can verify that it has worked.
Okay. So what happens is you
Yeah.
point, you click on the screen,
Point
the point
click,
gets
yeah,
generated,
exactly.
and then.
Okay, so then I've got another tiny screen to show you.
Okay, good.
Yeah, then if this is one that I actually collected earlier. This is kind of hard for you to see as well, but this is the point cloud that I collected and sent up. So then you've got it there, and then you can do whatever you want with it. So this, you can just interpret this as defects, and then maybe the next part is like actually adding some metadata to these defects so that you can name them or do more interesting things with them. But I think Nick is going to show you the next bit. Yeah.
Cool. So yes, so just to finish the process, the first step is to get all the data to Flux, as Tom just said. And Nicolas worked on data visualization. So basically generated the cloud. And Nicolas, if you want to say a few words about that,
Yeah,
that was great.
once we get these points inside the Flux, we can actually bring it to Grasshopper, and these points.
So they are
Okay, so the data captured, right, should actually be coming from the date captured. It should actually have the metadata with the date captured, the location of the defects, X, Y, Z into the space, and then the type of defects. We couldn't work on that part, but we tried to work on the first 2. For example, based on date logged in, right? For example, for defects rectification in architecture, the contractor has 14 days to repair it, and after that, it becomes a very important defect within 14 to 21 days. And above that, more than 21 days, it becomes a critical defect. And for this one, I kind of generated some points and some dates, and this is basically analyzing it and showing those where are the critical defects. For a small room, it's actually pretty okay. You can imagine that when you scale this to a building that's like 800 units, 800 residential units, you can actually find out where you have to send your defects team. So that's one of the possible applications of that. Basically to monitor defects team and make quick decisions to respond. And second part is because we only have the Z coordinate to work with. So one of them is you can actually find out what are the heights of the defects, which one is easily reachable, which one you have to bring a ladder to climb up and repair. So this possible application is it could facilitate the team deployments to know where to send them on site. And the last part is defects concentration. Again, you can actually monitor within the building where's the highest concentration of defects and deploy your teams there. Yeah, that's pretty much.
Cool. So actually we had a lot of fun playing with all these technologies, and what we realized that exchanging data between these different software was just a piece of cake, basically using the Flux platform. We do like SketchUp for fast modeling. We send the data to Flux. We catch data from Tango device, send the data to Flux, and then from Flux generate the data to send the data to Grasshopper for data 3D visualization, closing the full process. So thank you guys.